Right, section 13.3 is to solve systems of linear equations using the elimination method. And again, a reminder, 13.2 and 13.3 just form one homework assignment on MyMathLab. And regardless of the directions, you can use whichever method you prefer to answer the problems. Okay. So the elimination method, the point of this one is to eliminate a variable. Before we actually get into the steps for doing this, let me just give you a numerical equation here. If I said 5 plus 2 equals 7, you'd all agree with that, I hope. And if I said, let's say 8 minus 2 is equal to 6, you would agree with this equation as well. All right, what the elimination method does is say, well, what if I add these two equations together by adding down the columns? So 5 plus 8 is 13. 2 minus 2 is 0. And then 7 plus 6 equals 13. Does that make a true statement? Does 13 plus 0 equals 13? It does. That's a true statement. So what happens with with the elimination method is, what if I had the variables in here to make this a system of equations now? When you have that, you would end up with 13x plus 0y equals 13, or just 13x equals 13. You could divide both sides by 13 and you get the solution that x is equal to 1. So the point of the elimination method is to be able to eliminate one of the variables by adding the equations together. So we'll do an example, like a pretty simple one, and then I'll give you like the steps that you need to follow. So we have x plus y is equal to 8, and x minus y is equal to negative 2. So if I were to add these two equations together, x plus x would be 2x, but y minus y would eliminate, so I don't need to write that at all. And then I would say that's equal to 8 minus 2, which is 6. So to solve this equation, just divide both sides by 2, and we get part of our solution, which is that x is equal to 3. Then to find the y value, we would just take this 3 and plug it in for x. So we get 3 plus y equals 8. And then subtract 3 from both sides. So we get that our y value is equal to 5. All right. So the key is that in order to add your equations together, you need to make sure that the variable is going to eliminate. In order for that to happen, is that the coefficients of the chosen variable, that's whichever variable you want to cancel, must be opposites. Okay, that means, right, we had a positive one and a negative one here for the y's, so they would cancel out. If this was a 2, then this would have to be a negative 2, right? They have to be opposites. All right, so let's look at writing down our steps. Step 1, choose a variable to eliminate. Step 2 is that you're going to multiply one or both equations so that the coefficients of the chosen variable are opposites. And that'll make more sense once we do an example. Step 3 is that you'll add the equations together. And when you do that, when you add those equations together, that will eliminate that variable that you chose back in step 1. Right? And then in step 4, you're going to solve for the remaining variable. So you'll have x equals a number, y equals a number, whatever variable is left, you'll solve for that. And then in step 5, once you have the answer, you're going to substitute. Actually, I don't want to use that word here. I want to use substitute. I'm just going to say plug. Plug the solution from step 4 into one of the original equations. Okay, your first code word for this section is yellow. Okay, if you're not done writing this down, hit pause, because I'm going to delete it, and then just hit play again when you have it written down. All right, so let's do another example. X minus y equals -4, and x plus 2y equals 5. So if I were to add these two equations together right now, neither of the variables would eliminate, because x plus x would be 2x, and then -y plus 2y would be plus y, and then I get equals 1. So it doesn't really help me because I'd still have two variables left. So you have to pick, do you want to eliminate the x, or do you want to eliminate the y? And it really doesn't make a difference. Sometimes one of them is easier to eliminate than the other. In this particular case, I'm going to choose to eliminate the x, and I'm going to do that by multiplying this first equation. Actually, let me use a different color. I'm going to multiply the first equation by -1, because that would make this a negative x, and the second equation has a positive x. So now if I added those together, they would eliminate. So I was making sure that the coefficients of those x variables were opposites. But I can't just multiply the x by the -1. I've got to distribute that through. So this will make plus y. And then I also have to distribute it to the constant. So it's equal now to a +4, right? Multiply everything by the -1. Then my second equation would stay the same. So now when I add these together, again, the x's eliminate, they cancel each other out. My y's add up to 3y, and my constants add up to 9. So that was step 2 was this part, was multiplying by the -1 to make our coefficients opposites. Step 3 was the adding of them together. And then step 4 is to take this equation 3y equals 9 and solve. So it's pretty simple here. We'll just divide both sides by 3. We get half of our solution, which is that y is equal to 3. And then step 5 says take this answer y equals 3 and substitute it into one of the original equations. So either the first one or the second one, doesn't matter. I'm going to choose just to go into the second one here. So I've got x plus 2 times 3 equals 5. Well, 2 times 3 is 6, so I will subtract 6 from both sides. And x then is equal to -1. Okay. This particular system could have been very easily solved by the substitution method as well, so if you prefer that method, you absolutely can do it. All right, so let's look at another one here. X minus 3y equals -9, and 5x plus 4y equals -7. So you're going to pick a variable to eliminate for step 1. And in this case, the x would probably be easier to eliminate because I can multiply this first equation by -5, and that would make my coefficients the same. Right, so make sure you distribute that -5 through to everything. So we get -5x plus 15y is equal to a positive 45. Oops. Wait, what did I do here? Oh, sorry, I wrote something different down on my notes. I did it a different way. Anyway, and then the second equation stays the same. And again, we just were making sure that the coefficients here were opposite, same number, opposite sign. So when I add these together, my x's eliminate, and I get 19y is equal to 38. So I can solve this by dividing both sides by 19, and I get that y is equal to 2. And then I'm just going to take this 2, and you can plug it into either one of the original equations. This time I'm going to plug it into the first one. No rhyme or reason to that, just you can plug it into either one. So this would become x minus 6 equals -9. So I will add 6 to both sides, and I get that x is equal to -3. Your next code word for this section is sand, S-A-N-D, sand, like sand at the beach. Okay, our next example, 5x minus 6y equals 20, and 4x plus 9y equals 16. So this is a good example of a problem where the elimination method would be a lot easier than the substitution, because if you did substitution, there would be no way for you to avoid having fractions in your problem. Most people struggle with fractions, so we like to use methods where we get to avoid them. So we're going to pick a variable to eliminate here, x or y, doesn't matter which one. And in this problem, one of them is not any easier than the other, so it really truly doesn't matter. So I'm just going to choose x. So I need this 5x and this 4x to turn into the same number but opposite in sign. So you kind of want to think, well, if you had a denominator of 5 and a denominator of 4, what would your common denominator be? It would be 20. So you need to change both of these problems so that they're 20x. But one of them needs to be negative. It doesn't matter which one, so I'll just do the second one. So in order for that to happen, you would have to multiply the first equation by 4 and the second equation by -5. So if I distribute this 4, I'm going to get 20x minus 24y is equal to 80. And then if I distribute the -5, I get -20x minus 36y is equal to -80. So now when I add these two equations together, the x's eliminate, and I have -60y. Except, what did I do wrong here? Oh, what's 5 times 9? Sorry guys, this should be 45. Making that a -69y. Right? And then the 80 minus 80, these constants over here, these also eliminate, so that's going to be equal to 0. But we do still have this variable y in here, so we can keep solving by dividing both sides by -69. And I get that y is equal to 0. So I have part of my solution. And we'll take this 0 and plug it back into either of the first two equations. It doesn't matter. I'm going to go into the second one again. So I get 4x plus 9 times 0 equals 16. So 9 times 0 goes away. So I'll just divide both sides by 4. So my solution is 4, 0. Okay, the next example, 2x minus 8y equals 6, and 3x minus 12y is equal to 9. So we're going to pick a variable to eliminate, and this time I'm going to choose to eliminate the y. So I need to know what number could I turn 8 and 12 into, like if those are my denominators, what would the LCD be? And it would happen to be 24. So I'm going to multiply the first equation by 3 and the second equation by 2. But if I do that, they'd both still be negative. So I need to multiply one of them by a negative. So we can just multiply the second equation here by negative 2. This turns my first equation into 6x minus 24y is equal to 18. And then the second equation would be negative 6x plus 24y is equal to negative 18. Right? So when I add these equations together, I eliminate my x's and I eliminate my y's. So this whole side is gone, meaning that that side is equal to 0. And then 18 minus 18 also cancels, so that's 0. So we're left with no variable. And this is where again we ask ourselves, well, is what we are left with true or is it false? And 0 does equal 0, it's true. That means that there are infinitely many solutions. And this particular problem wants us to actually answer in a different way. First, it's going to say something about it being a dependent system. And then it's going to give you something that looks like this. An ordered pair xy such that y equals, and then you have a box here. Okay. And this is just telling us that we do have infinitely many ordered pairs, but we can't just pick any like random set of ordered pairs. I can't say, well, oh, 1, 2 is definitely a solution. So what you're going to have to do is take one of your equations and solve it for y. So I'm going to take the 2x minus 8y equals 6, and I just need to isolate this y here. So I'm going to subtract 2x from both sides. And then I'm going to divide everything by negative 8. So I get y is equal to negative 3/4, right, reduce this fraction, and then plus 1/4 x, again because I reduced this fraction. So this part is what you need to enter for your answer. Y has to be equal to negative 3/4 plus 1/4 x. I know that's a weird one, but it's just saying if you pick a value for x, you'd have to plug it into here, and then it would get you what your value is for y. All right, one more example and then the section is done. 3x plus y equals 6, and 6x plus 2y is equal to 4. All right, so I'm going to choose to eliminate the x, which means I just need to multiply the first equation by 2. This would make negative 6x minus 2y is equal to negative 12. And then the second equation, 6x plus 2y equals 4, stays the same. So when I add these two equations together, I again eliminate the x and eliminate the y, meaning I have no variable left. But this time my constants, negative 12 plus 4, would become negative 8. So again, no variable. Is what you are left with true or false? Does 0 equal negative 8? It's false this time, which means there is no solution. And this is called an inconsistent system. Okay, so this would be our answer. There is no solution. Your final code word for this section is trust. T-R-U-S-T, trust.